In this video, I would like to talk about additional log properties that we didn't quite get to last time. I know we talked about the first four properties that I'll quickly review. So log of any base of 1 is 0. That is actually true because again, a to the power of 0 is equal to 1. Exception would be 0 to the 0, but we don't have to worry about that base. Now log base of a is equal to 1. Log base of a to the x is equal to x, they cancel each other, or a to the power of log base a of m is equal to m, they also cancel each other. Now we'll learn three more properties that would be very useful, and they actually make it true from the properties of logarithms. The log of a product, we can break it up as a sum of two different logarithms. And that sort of stems from the exponent properties. If you recall that logarithms are sort of like exponents, that's the way they're defined. Then it's a to the x times a to the y. If you recall, that is equal to a to the power of x plus y. So it's sort of the same thing if you think of logs as exponents. So the product becomes a sum, essentially, of two different logs. Now the log base a over quotient m divided by n is equal to log base of m of the top minus the log base a of n. So again, what was in the denominator also becomes negative, sort of like the exponent. Or you can also subtract the exponents if you're dividing. Now it does not work the other way around. You cannot break up log of the sum or log of a difference. Okay, so the same thing, you cannot do it with exponents actually, like x plus y squared, you cannot just break that up. Now, here is another one, and that's power of a power. And that's log base a, but what if we have x to the r? It could really be any x, it doesn't have to be the same as the base. What we can do is take that exponent r, put it on the front, and it's essentially r times log base a of x. And it becomes a coefficient rather than an exponent. So we can take down any exponents and put them on the front. And it's really coming from the power of a power. A to the x to the power of y is a to the x times y. I mean, I really try to, when I try to remember these properties, if you think about, let's say, x cubed squared, it's the same thing as x cubed times x cubed, which really, if you think about it, there's 6 x's, so it's x to the 6. So notice it is actually a product. That's 3 times 2 is also going to give us 6. So all the properties really fit together, and the same thing with logs. So, and there is one more change of base, that is if you don't have that function in the calculator that I talked about in the last video for section 3.2, check that out first, then you would need to use change of base to use log of base of any base of other than 10 or e, which is in your calculator. So let's say log base a of m, you want to switch it to, let's say, base b, it becomes a quotient of log base b of m divided by log base b of a. So really, if we use it with log or ln, then it becomes, if we think about it, is the same thing as log of m divided by log of a, and you can do the same thing with ln. So now let's take a look at some examples of how we would use these properties. For example, if you want to rewrite it in the expanded form, of course, let's take a look. Let's say ln of x times x minus 1. Well, notice there is a product, so how can we break this up? Well, this would be ln of x plus, because of the product of ln of, if there's more composite terms like x minus 1, we can put them in parentheses. Around x you can put parentheses or not, it just depends. And that's it pretty much. So it's a very relatively simple example. Notice how I do have it typed out. Okay, what about something more complicated? Let's say you have a division. So you can get started with a subtraction. So you can start with the square root of x squared plus 1 minus log of x plus 3. So you can break it up in the, sorry, I think my pen just kind of stopped here. So you can rewrite it as subtraction first, but then let's deal with the exponents. What about the exponents? What what about the square root, which is considered to be the exponent, so you can actually rewrite it as the log of the whole thing, x squared plus 1 to the 1/2 power. Be careful, you actually cannot take the square root of x squared plus 1. It does not equal to x plus 1 because of the plus. I mentioned you cannot easily break up pluses or minuses. Of log of x plus 3. Okay, and then you can take the 1/2 down, and then we'll have 1/2 log of x squared plus 1 minus the log of x plus 3. Okay, so I'm basically showing you this is how I would work it out, and I have the type solution right before. It's probably right in front of you. So you use several properties here. Okay, but mainly we use the one with the subtraction, and then the one with the exponents. Okay, so then you can work backwards. What if you're trying to write it in the condensed form? Sometimes you want to make it a single logarithm. Well, if we have log base 2 of x plus log base 2 of 7, well, that becomes log base 2 of 7 times x, or 7x. What if we have a constant 1/5 in front, and then we have log base 2 of z plus 2 log base 2 of y? How would we do this? Then I'll probably start compactifying the inside of the parentheses first. Notice how I brought the 2 as the exponent. You want to do that before bringing them together as one log. So it becomes y squared. Notice then it becomes a product of z times y squared. And then at the very last, you can bring up the 1/5 as the exponent. So now you have a single log of zy squared to the 1/5 power. Okay. Now, what if we have 2 ln of x minus 1/2 ln of x squared plus 1? It's similar to what we had earlier. Let's bring up the constants first as exponents. So it becomes ln of x squared minus ln of x squared plus 1 to the 1/2 power. Should seem familiar from the other example. Then it becomes ln of x squared over square root of x plus 1. And then that's it, really. So we can leave the square root in the denominator for these. Okay, change of base. This is what I mentioned earlier, how we can do it as log of m divided by log of a, or ln of m divided by ln of a. So this is what you can do. Let's say if you're trying to calculate log base 2 of 5, and you don't have the alpha window, option 5, or math, option A, in your calculator, so this is what you can do. You can rewrite it as basically ln of 5 divided by ln of the base, which is 2. Or you could have really used the log and get the same answer. See how I wrote it as also equals to log of 5 divided by log of 2. And that is equal to, then you click enter, it's 2.322. Make sure close parentheses when you're doing these, because otherwise you may get something else. But that's what I have. And the same thing with the log of base 1/2 of 3. You can rewrite it as ln of 3 divided by ln of 1/2. The ln of 1/2 is actually negative, so that gives us a negative answer, negative 1.585. And that's it for this section.